Hello Fahad, my voice is on. You have a doubt, Fahad? Okay, so Fahad, we can discuss your doubts after the class. Okay? Okay, Fahad? Uh, my voice is audible? Okay. Okay, Fahad. So, in our backup classes, we we have done the we have checked that what is a relation. Okay, what is the types of relation? We were doing this. Just give me a minute. Okay. So we have already done the inverse of a relation. Okay. After that, we have a types of relation first. So do we have completed void relation? I guess we have done the void relation. Yes, we did. And then we have a universal relation. We have done this one. Universal? No. No. Okay. Okay. Then we will check for universal relation. What is a universal relation? Let A be the set. Then a relation R on a set A is called universal relation if each element of A is related to every element of A. So what does this mean? This means, suppose we will take example, we have this relation on this set. Set is 1, 2, 3, 4, 5, 6. Okay. And this is the relation. Modulus of A minus B will be greater than equal to 0. Okay, this is the relation. Modulus of A minus B is greater than equal to 0. Then which value can we choose from this set A, which value will satisfy this relation? All the values will satisfy. If you will choose any value and you will subtract it, as we have a mod, that's why the answer we will get will always be greater than equal to 0. Okay. So we will take example. So in this case, for example, if we will take 1, then 1 will be related with 1, 1 will be related with 2, 1 will be related with 3. Yes, you are correct, because there is a mod. That's why we will always get a positive answer. 1 comma 5, 1 comma 6. Next we have a 2 comma 1, 2 comma 2, 2 comma 3. Okay, 2 comma 4, 2 comma 5, and 2 comma 6. Similarly, we can find all the ordered pair. So here every element will be related to each element of set A. Because we have a modulus and the answer should be greater than equal to 0. That's why we will take all the elements. This is the universal relation. Please again check the definition now. Let A be a set, then a relation on a set is called universal if each element of A is related to every element of A. Okay, if each element of A is related to every element of A. So we can see here, if we will take this one, then 1 will be related with all the elements. If we will take 2, 2 will be related with all the elements. Similarly, 3, 4, we got then here 3, 1 and so on. Then we will get 4, 1 and so on. Then 5, 1 and so on. 6, 1 and so on. Okay. So this is the universal relation. Okay. So what is a universal relation? Where each element of set A will be related to every element of A. This is clear, first. Okay. Okay, so you can note down this definition. So if you will check the void relation and universal relation, then universal is just opposite of the void relation. In void relation, we do not have any element. In universal relation, we take all the elements. Okay. So please note down this and confirm me, then we will start the next topic. Okay, first, please let me know once you complete this. Okay, good. Okay, so please note here, uh, void relation, and universal relation on set A are respectively the smallest and the largest relation on a set A. Okay, I hope this point is clear to you. We know that in void relation, we do not have any element. That's why this is the smallest relation. And in universal relation, we take all the elements. Okay. In universal relation, we take all the elements. That's why the universal relation is the largest relation. Okay. Next thing is both the empty or void relation and the universal relation are sometimes called trivial relation. Okay, so empty and universal relation, they are also called trivial relation. There's a name for this. Okay, these void and universal are also known by this word, trivial relation. So if in question they ask you about the trivial relation, that's mean they're asking about the void and universal relation. Okay, so please note down this and confirm me. Then we will start the next part. Okay, right. Good. Next. This next we have a identity relation. Okay. We have already completed the reflexive, symmetric, and transitive relation. Next, we have a identity relation. Okay. So, what is the identity relation? A relation on A is called the identity relation if every element of A is related to itself only. Okay. Now you have already completed the identity and you have already completed the reflexive relation. So can you tell me the difference between the identity and reflexive? Please turn your pages, check the definition of reflexive relation. Yes, it's like AA, but in reflexive also we have a, so what is the difference between identity and reflexive? Same? No, not same. There is a difference of this one, this word only. So in this definition, they are saying that every element of A is related to itself only. Okay. So for example, yeah, I'm taking example. For example, if we have this set, then this relation 1, 1, 2, 2, 3, 3, we will say that this is an identity relation. Suppose if we need to find the reflexive relation, then reflexive relation can be this one. Reflexive relation is 1 comma 1, 2 comma 2, 3 comma 3, okay, 1 comma 3. Okay, if we will take this as an example, then this is a reflexive relation. But can this be identity relation? No, this can't be an identity relation because 1 comma 3 is there. So in identity relation, the elements of set A is related to itself only. And what happened in reflexive relation? Element of set A is related to itself. So that means in reflexive relation, we can have the other ordered pairs. But these should be must. These should be present in the relation. Other than this, you can have any other ordered pair, then it will be a reflexive relation. But in identity relation, you must have only these. Other than this, you should not have any other ordered pair. Okay, this clear first? It can. Okay. Okay. So, for example, this one. Okay, these are not the identity relation. Why this is not identity relation? Because 3 comma 3 is missing. If we will take this example, this is also not an identity relation because 1 comma 3 is present, which is not possible in case of identity relation. Yes, this is a reflexive, but this is even not a reflexive. Okay. Okay, fine. Please put down this one. Yes. We will discuss the reflexive part. Okay. First of all, please note down this. Please let me know. Okay, first once it is done. Okay, so first we will check the definition of this reflexive relation. Okay, so if you will check here, then the definition is a relation on a set is said to be reflexive if every element of A is related to itself. They are saying that every element of A is related to itself, and if we will check the identity, they are saying related to itself only. Okay, now for example, suppose we have this set, then this relation, this is a reflexive relation. Why? Because these elements are related to itself. In set A, you have three elements, and these three are related to itself. Other than this, you can have any ordered pair in case of reflexive relation. Okay, but for identity, you don't have any other ordered pair except these. Okay. Now, if we will check the second example, this R1, this is not a reflexive because this one. Uh, we have a 1 1, we have a 3 3, but we do not have 2 2. Yes. That's why this is not a reflexive. Okay. Now this is clear for the difference between the identity and the reflexive relation. Okay, very good. So we can check this point. The identity relation on a non-void set is always reflexive relation on A. Okay. However, a reflexive relation is not necessarily the identity relation on A. I hope this statement is clear to you, that every identity relation is a reflexive relation. That's correct. But the converse of this statement is not always be true. That means a reflexive relation is not always the identity relation. For example, we can check this one. This is a reflexive relation, but this is not identity. If you will check a previous example, this is identity relation and this is also a reflexive. So all identity relation are reflexive, but all reflexive relation can't be identity. Can't be identity. Some reflexive relation can be identity, some cannot. Okay, but this is clear. Okay, very good. So please note down this, confirm me, then we will check the next treatment. This is done for. Okay. 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 Then please note down one more point, that this one, that universal relation on a non-void set is reflexive. We know that in universal relation, we will take all the ordered pairs. That's why it will become a reflexive relation. Okay, because in universal relation, these ordered pair will also be included. Yes, yes, we will do. Okay, fine. So first, please note down this last point. Universal relation on a non-void set is reflexive. Shall we start next first? We can take the same example. For example, if we have this set 1, 2, 3, we need to find the universal relation. Okay, then in universal relation, what ordered pair we will get? We will take all the ordered pair. For example, 1 comma 1, 1 comma 2, 1 comma 3. Then 2 comma 1, 2 comma 2, 2 comma 3. Then 3 comma 1, 3 comma 2, 3 comma 3. Okay, because there's a universal relation, so we will take all the ordered pair. Now you can see here, if we will take all the ordered pair, then definitely these will always be included. Okay, that's why this is always a universal relation. This clear for? Yes, this is a universal relation, and this will always become a reflexive because these ordered pair will always be available in this relation. Okay, so shall we start next first? Okay. Okay, so questions, there's no need for the question because you understood this. Now, symmetric, you already know that what is a symmetric relation. Okay, so what is a symmetric? If AB is there, then BA should also be there. Then only we will say that the relation is symmetric. Identity and universal relation are always symmetric relation. Why identity is symmetric? Because 1 comma 1 is there and its opposite is also 1 comma 1, same ordered pair. That's why this is a symmetric relation. Why universal is a symmetric relation? Because you already know that in universal you will take the all the ordered pairs. So that's why the opposite of any ordered pair will always be present in the universal relation. For example, if we have 1 comma 2, if we have 1 comma 2, then its opposite is 2 comma 1. So in universal relation, if you will take all the ordered pairs, then definitely it will present. So for example, please check this. We have found this a universal relation. Okay, 1 comma 2 is present, then please check its opposite is what? 2 comma 1. It is also present. 1 comma 3 is present, its opposite is 3 comma 1. It is also present. Then you have a 2 comma 3, its opposite is 3 comma 2. That's This is clear first. Okay, very good. So Ananya, as I already told you that you all need to join 30 minutes earlier so that we can discuss the previous topic which you have missed. Okay, so please try to join 30 minutes earlier every week. Okay, so first please note down this point and confirm me once it is done. Okay, you have a class till 6:30 on Saturday and Sunday both or only on Saturday? Okay, okay, okay. So only on Saturday or on Sunday also? On Saturday. Okay, Ananya. Then what we will do, we will do the extra class only on Sunday then. Okay. First, please confirm if it is done. Rifat, we are just discussing the topics which the new students has missed. Okay, so almost we have completed all the topics. We will continue the topic of today's class in 2 or 3 minutes. I'm just waiting for the other students. Okay. Okay, fine. So what is a transitive relation if you have this ordered pair, the relation R, and you have this ordered pair in the relation R? Okay, please check here. If the last element B is here, then this B should be the first element of this ordered pair. If these two are present, these two are same. Okay, so please cut this one. So what you will get? A comma C. So what is a transitive relation? If A comma B belongs to R, B comma C belongs to R, then A comma C should belongs to R. From where we will get this A comma C? This we will get from here. Okay, so please remove the common part. Then the remaining element, please do not disturb the ordered pair. Here the first element is A, so we will write A. Here the second element is C, we will write C. So A comma C belongs to R. Okay, so this is a transitive relation. This clear first? Okay. Then we will wait for 2-3 minutes. Okay. Let's other will join. Then we will continue our last talk. Sorry for. Will you please explain? Okay, so not transitive. Next is identity and universal relation are. Identity and the universal relation on a non-word set are transitive. Okay, because in identity we have the common element. In universal relation we take all the elements. Okay. There's a one more point. Then when we will say that the relation is not transitive. Okay, there's a very important point. When we will say that the relation is not transitive, suppose we have this relation R, AB. We have second ordered pair BC. Okay, when we will say that the relation is not transitive, when we have a first and second, when we have first and second ordered pair, but the third is missing. So AB and BC is there, but AC is missing. Then we will say that this is not transitive. Okay. When we will say that this is not transitive, then when first and second ordered pair, this one and this one, just here. Okay. So when first and second is present and third is not present, then we will say that this is transitive. Sorry, when first and second is present and third is not present, then we will say that this is not transitive. Okay. Okay. So I hope these 2 points are clear. When we will say it is transitive, when first, second, and third is present. When we will say that this is not transitive, when first and second is present and third is not present. Okay, then we will say it is not transitive. But what happens if you have only A comma B? You even do not have this and this. So what we will say, always in exam write this statement that A comma B is present and there is no other ordered pair. Okay, you don't have even this one. Okay, so we will say that A comma B is present. There is no other ordered pair. That's why it is transitive. Okay, this point is quite confusing. So remember in this way, if you have only a single ordered pair, then you will say that as the second ordered pair is also missing, so it is transitive. Okay. So please remember this one. So let me check for other students, okay? Then we will continue our class. For very good question. So if you will take this one, A comma B, and you are saying first and this is present, A comma C. Okay. So if you will check this, then definitely first and second again are not present. So we will say it is transitive. Okay. We need to focus on this one, first and second. Okay, because there is no match. That's why it is transitive. Okay, so everyone has joined. So now we will continue our topic. Uh, it is transitive. Okay, we need to focus on this one. Okay, we need to focus on this. First, second present, third not present, then not transitive. First is present, okay, and this second is not present, then we will say it is transitive. Okay, you can have any other or other ordered pairs. For example, in this case, you are saying that this is present. It's okay if this is present because we can't match these two, so it is transitive. Okay, so just focus on the first and second part. First, second present, third not present, not transitive. Only first is present, second is not present, then transitive. Okay, just give me a minute. I will check for that. Then we will start our class. Okay, then we will continue our last topic. Okay, everyone has done the homework. Abdul, Ananya, Fahad, and Rifat. You have completed the homework. You can message me on the chat box. Everyone, please message me on the chat box. I'm sorry, anyone can remind me that how many questions we have completed? I guess this question I have given in homework. And what about this fourth one? We have completed this question. I guess we have done. Abdur, Ananya, Fahad, Rifat, could you please check and confirm? We have completed. Okay, thank you, Rifat. Okay, so I guess we have not yet started this question. Okay. This I have given in homework, Rifat. Anu, Rifat, Abdur, Fahad. This question I have given in homework. No. Okay, okay, okay. Then please start this question. This is a very good question. This is from your NCRT and this also came in CBSE 2009. Okay. So please try this. Equivalence relation, you know what it is. So please try this and then I will help you. Yes, Fahad. Okay, I hope everyone know that how to solve this question. Okay, we have already done many questions like this. Let me explain this to you. Shravya, you have joined after some days. So, Shravya, you will continue in this batch or you will join in the last batch only? Uh, Sorry, Shravya, your voice is not audible, Shravya. You can message me on the chat box. Okay, so in the meantime, I will start this question. First is we will check about the reflexive. Okay, so for reflexive, what we always do, we assume a value from the set. Let A belongs to set A. First of all, we will assume this value. Okay, now we will put the condition which is given here. Condition is this one, A minus B. So here let A belongs to A. Next we will write A minus A is what? A minus A modulus is 0, which is even, which is even. Okay, this implies A comma A belongs to R. Hence, relation R is Hence relation R is reflexive. Okay, so this is clear. Abdur, Ananya, Fahad, Rifat. First point is clear. Please confirm. Abdur, Ananya, Fahad, Rifat. Please confirm me on the chat box. This is clear. So the number, yes. What is reflexive? Same element should be related to itself. So what we have done here, we have assumed a value from the set A, and we have found out its difference. So we will always get a 0. For example, if you will take 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, you will always get a 0, which is an even number. Okay, so that's why this is reflexive. Okay, so now we have the second point. Second is symmetric relation. Symmetric relations. Okay, so please remember what steps you need to do in symmetric relation. What we always do, we assume two values. Let A comma B belongs to R. Okay, these are the standard steps. We'll assume in this way, let A comma B belongs to R such that A comma B, sorry, why R? A. Okay, first of all, we will assume two values from the set A, and we will assume that they belongs to the relation R. Okay, these are the fixed steps. So please remember these such that AB belongs to R. This implies modulus of A minus B is even. Okay, if this ordered pair A comma B belongs to R, then modulus of A minus B is even, because this is the condition which is given. Okay, now what we need to prove? We need to prove that BA should also belongs to R. Okay, so for BA, what we need? We need B minus A. Now here we are saying that modulus of A minus B is even, then we can also say that modulus of B minus A is also even. Is also even. For example, if we will take 1 minus 3, we will get a 2. If we will take 3 minus 1, we will again get a 2. So if 1 minus 3 is even, then it's 3 minus 1 will also be even. The same thing we are saying here, that modulus of A minus B is even. This implies B minus A is also even. Okay, so we can say hence A comma B belongs to R. This implies B comma A belongs to R. So the relation R is, so the relation R is, so the relation R is symmetric. Okay. So I already told you that you will face only this issue, that how to represent your answer. Okay, so remember, in reflexive you need to assume a value, you need to put the condition, then you need to write the reflexive. In symmetric, you need to assume a value, you need to assume a ordered pair from the relation R, you need to find its opposite. Okay, so everyone please note down this, confirm me or raise your hands. Okay, then we will check for transitive. And till tomorrow, please complete your homework. Okay. Okay, Ananya. In class, also, I have given some questions from this PPT. Okay, so please complete those questions. Abdur, Fahad, and Rifat, please confirm if it is done. Okay, Rifat, good. Okay, Abdur. Fahad, this time. Okay, great. Now we will check for transitive. Okay. Again, in transitive, we have the fixed strips. Okay. Anyone can tell me what is the fixed strip here? Late. In transitive, we assume three values from the set A. We're very good for. Okay. Such that we also assume this such that A comma B belongs to R and B comma C belongs to R. B comma C belongs to R. Okay, such that AB belongs to R and BC belongs to R. This implies modulus of A minus B is even and mod and modulus and modulus of B minus C is even. Okay, so for transitive, we are saying that AB belongs to R and BC belongs to R. So that means A minus B is even and B minus C is even because there's a condition. Abdul, this we need to prove. AC we need to prove. What is the transitive? AB, BC should belongs to the relation R. We need to prove AC should also belongs to R. Okay. So in starting, what we will do, we will assume three values and then we will write that this and this belongs to the relation R. Okay, Abdul? Okay, so we will prove this part that AC is also belongs to R. Okay, so these two are fixed. Now, when these are even A and B, so in the bracket we will write either A and B are even or odd. Are even or odd. Okay. A minus B is even. So we can say either A and B are even or odd. Similarly, here we can say B and C are even or odd. So are even or odd. Okay. So what is mean by this? We know that if we subtract two odd number, then we will get a even number. For example, 3 minus 1, we will get a even number. Similarly, if we will subtract two even number, then we will get a even number. Okay, you know this point. If you subtract two even number, then you will get a even number. If you will subtract two odd number, then you will get a odd number. So the same thing we have written over here, that the modulus of A minus B is even. That means either A and B are even or odd. Modulus of B minus C is even. Then either B and C are even or odd. Okay. Please raise your hand if this is clear to all of you. Okay, Ananya. Good. Okay, Abdul. Good. Okay, Fahad. Good. Rifat, this clear? Rifat, please confirm if this is clear. Now we will take two cases. Rifat, please confirm if this is clear to you. Please reply me on the chat box or you can raise your hands. Okay. So here what we are saying that A minus B is even. So that means either A and B are even or either they are odd. So we will take two cases. First, B is even. B is even. Okay. So B is even and A minus B is even and B minus C is even. So in case first, we have assumed that B is even. We already know that A minus B is even and B minus C is even. This implies A and C are also even. Okay, this point is clear. We have assumed that B is even. Now, modulus of A minus B and B minus C is even. That's why we can say that A and C are also even. If they both are even, then A minus C is also even. Why this is even? We can write in the bracket. Difference of two even number is even. Difference of two even number is even. Okay. Okay. Now we will take case two. Case two. Okay. Before that, so this implies A comma C belongs to relation R. Okay. Now we will take case two. B is odd. Now we know that modulus of A minus B is even and modulus of B minus C is even. This implies A just give me a minute. This implies A and C are odd. Okay, so we can say that modulus of A minus C is even. Okay, because we know that difference of two odd number is even. Difference of two odd number, two odd difference of two odd number is even. So this implies A comma C belongs to relation R. Okay. But finally, we can say A comma B belongs to R, B comma C belongs to R. This implies A comma C also belongs to R. Hence, relation R is transitive. This is clear to all of you. Of case two, yes, we can take any example. For example, B is odd. So from the set which is given in this question set is 1, 2, 3, 4, 5. Okay. So just take any two odd number. For example, you have the number 1, 2, 3, 4, 5. So you can take 1 and 3. Next, you can take 3 and 5. Okay. So 1 minus 3 is odd. 3 minus 5 is also odd. Now remove this common parts. You will get 1, 5. This is also odd. Sorry, this is also even. Difference of 1 and 5 is also even. Clear for? Okay, very good. So everyone, please note down this and confirm me. Okay, if this is clear, then we will start the next question. Okay, so Shravya, you have again joined. So you will continue in this batch only? Okay, so Shravya, we have completed the matrices and determinants. Now we are doing the relation and functions. Okay, but some new strengths are there. So matrices and determinants we will again do. Okay, now in relation function we have two parts: relation and functions. I guess you will not be able to understand right now relation. Okay, but from when we will start the functions, then that will be clear to you. Okay, so please wait. I'm not sure, but maybe if we will get the time, then we will start function today only. Okay, okay, this is done in your school. Okay, sure, yeah, no issue, but we will give you the backup classes, or we will share the recorded lecture with you. Okay, so please wait. Maybe we can start function today on. Okay. So, Shravi, how many chapters you have completed in your school? Okay, okay, mm-hmm. Okay, and inverse trigonometric function. Okay, so right now which chapter is going on? Shravya, right now which chapter is going on? Um, right now you are doing which chapter in your school? Is it differentiation? Then everyone please raise your hand once it is done. Okay, Abdul, good. Okay, okay, Shravya, understood. Okay, Rifat, good. Okay, Shravya, very good. Okay, so everyone has completed this. Fahad, please confirm this is done. Shall we start next? Okay, okay, very good. So all of you have completed this one. Now please check. Now in the same question, there is one more part where they are saying that show that all elements of 135 are related to each other, and element 24 are related to each other, but no element of 135 is related to any element of 24. So we already know here. Okay, we already know that if we will subtract two odd number, we will get an even number. If we will subtract even number, we will get an even number. Okay, so these are odd number. We can write the statement here: difference of odd number, difference of odd number is an difference of odd number is an even number. It's an even number. Hence elements 1, 3, 5 are related to each other. Are related to each other. Okay. Next, difference of even number. Difference of even number is an even number. Hence, elements elements 2, 4 are related to each other. Are related to each other. but no elements of 135 is related to any element. Now we will say that difference of even and odd number, difference of even and odd number is difference of even and odd number is not even. Hence 135 is not related to the same thing. Hence no elements, of 135 is related to any element of 2 comma 4. Okay, so I hope this is clear to everyone. Please note down this, then we will start the next question. Please raise your hand once it is done. Okay, but please check here. So if you will subtract any two odd number, for example 1 minus 3, you will get a even number. If you will subtract two even number, you will get a even number. But if you will subtract one odd and one even number, then this is odd. This is not even. The same thing. We are saying here, that 1 3 difference of odd number is an even number. Okay, that's why 135 will be related to each other. 135 is an odd number, so they will be related to each other, because if you will subtract them, you will get an even number. 2 4 are even numbers, so if you will subtract two even numbers, you will get an even number. Okay, now here we are saying, but no element of 135 is related to 2 4, because this is odd and this is even. You already know if you will subtract odd and even, then you will get what? Odd number. The same thing we have written in point third. This clear? But okay. So Ananya, good. Abdul, Fahad, uh, Rifat, please confirm if this is okay. But please confirm if this is done, so that we can start. Okay, Rifat. Abdul, this is done. Shall we start next question? Okay, very good. Okay, then this is also a very good question. You can see here, this is of NCRT and came in CBSE 2010, then 2018, then 2019. Okay, so we can say this is a very, very important question. So please try to solve this question. This is your set, x is an integer, and the value of x is from 0 to 12. Okay, given by a minus b is a multiple of 4. Yes, yes. Okay. So remind me tomorrow. Okay, for actually in the beginning, I have already explained to the students that which exercises has been deleted from the first part. Okay, so I will again do the same thing with your batch. Tomorrow, I will let you know that which exercises, which topic has been deleted. Okay. Okay, so question number 6 says we have this set where the numbers are between 0 and 12 given by a minus b is a multiple of 4. This is the condition. This is a multiple of 4 is an equivalence relation. Find the set of elements related to 1. Okay. Uh, okay, Abdul, we will discuss this about this. Okay. Because as per the recent recent syllabus which is released by CBSE that was deleted. We will check this tomorrow. Okay. Next question number 6. Please try this one. Show that this is an equivalence relation. Okay. Please try this and confirm me once it is done, or if you have any doubt, then I will do this question. I hope everyone has completed this. Okay.
Yes, sir.
Okay. So I will solve this. Please check your steps. Now, first is reflexive. Okay. So in reflexive, what we always do, we will assume let A belongs to A. We will write A minus A, which is 0. It is a multiple of 3, is 0, which is a multiple of 4, which is a multiple of 4. This implies A comma A belongs to the relation R. Okay, hence relation R is reflexive. Okay, second one, symmetric. Yes, for symmetric. What we do always in symmetric, we assume two values, let AB belongs to A, such that we assume one value, such that A comma B belongs to R. So that means this implies A minus B is a multiple of 4. Is a multiple of 4. Now we know that modulus of A minus B is equal to modulus of B minus A. Okay, because it 1 minus 2 is what? Minus 1. If you'll find this 1 minus 2, then this will give you 1. If you will find 2 minus 1, you will again get 1. So A modulus of A minus B is equal to modulus of B minus A. So A minus B mod is a multiple of 4. This implies B minus A is also a multiple of 4. Okay, this implies B comma A belongs to the relation R. Hence, A comma B belongs to R. This implies B comma belongs to R. So relation R is symmetric. Is symmetric. Okay. So please note down this and raise your hand if this is done. Then we will do the transitive part. Okay, Shravya, very good. Okay, Ananya. Abdul, Fahad, Rifat, please confirm. And Hiba, I guess you have not joined the right batch. This is class 12, maths class. Okay. Okay, thanks everyone. Now we will start the transitive part. Okay. So what we always do in the transitive, third is transitive. Okay. So in transitive, we always assume three values that A, B, C belongs to R, belongs to A, such that uh, Hiba, you have just joined. This is your first class. Okay, okay, okay. Okay, Umir. Umir, please take the screenshot of this. Okay. Is it done, Umir? Umir, please take the screenshot of this. Is it done? Umir, is it done? Okay, so transitive, let ABC belongs to A such that we assume two values such that AB belongs to R and BC belongs to R. Okay, so what does this mean? This means A minus B is a multiple of 4, is a multiple of 4. B minus C is a multiple of 4. Okay, now this means what? A minus B is a multiple of 4. Please see this one. 12. We can say that 12 is a multiple of 3. 12 is a multiple of 3. So we can write it like this: 3 into any number. 12 is a multiple of 3. That's why we can write 3 into any numbers. For example, 15. 15 is a multiple of 3. We can write 3 into any number. Suppose we have a 20. If we will say that 20 is a multiple of 5, then we can write 5 into any number. So in this case, you know that here we will have a 4, here we have 5, here we have a 4. So what the logic is, if any number is a multiple of any number, then we can write that number into anything. So similarly here, uh, we are saying that A minus B. Yes, that's correct, Abdul. So we can say, very good, Abdul. So we can say that A minus B is equal to 4 lambda. And here we can say B minus C is equal to 4 nu. Okay. What is a lambda and nu in this case? Lambda, where lambda and nu belongs to the natural number. Okay. So I hope this point is clear to everyone. Why we have written this 4 into lambda and 4 into nu? Because it is a multiple of 4. As we discussed previously, that any number is a multiple of any number, then we can write that number into any number. So, and what is this lambda and nu? This is a natural number. Okay. Now, if you always remember, if you remove the mod, then you get this one, plus minus 4 lambda. And here you get what? Plus minus 4 nu. Let this be 1. Let this be 2. Now add 1 and 2. Why we are adding 1 and 2, we will get to know in the next step. If you will
To
add...
cancel B?
Yes, to cancel B. Very good, Umar. Okay, so if you will add these two, then you will get A minus C, which is equal to plus minus 4 lambda plus minus 4 nu. Now here you get A minus C, which is equal to, take 4 common. Here you have a plus minus lambda plus minus nu. So this number A minus C will also be divisible by 4. We can say A minus C is a multiple of 4 because you have a 4 in the starting. So you can say A minus C is a multiple of is a multiple of 4. So modulus of A minus C is a multiple of 4. Okay, so A comma B belongs to the relation R and B comma C, hence B comma C belongs to relation R. This implies A comma C belongs to relation R. Hence, given relation is a transitive. First, just give me a minute. I will check your question. Is a transitive. Lambda can be any number. That should be a multiple. No, no, no. Just. Yeah. So, first your question is lambda can be any number. That should be a no. Lambda can be any natural number. Okay, so for that means you can put the value of lambda as 1, 2, 3, 4, 5, 6, anything. Okay, if you will put any value, any natural number in place of lambda and nu, if you will put any number, then what the final results you will get, that will always be a multiple of. Okay, for example, please in place of lambda put 1. What do you get? 4. 4 is a multiple of 4. In place of lambda put 2. What you will get? 8. 8 is a multiple of 4. Okay, for I know your query is that we have only this limitation. Yes, so we will not put, yes, that's correct. Then we will not put 4 because that will be a, just give me a minute. The set is 12. Okay, so A minus B is a, okay, then we will select the value uh, up to 12 only from this. Okay. So that's correct. That's correct that we have a limitation because of the sets. Okay, but there's no need to explain that. That is understood. Okay, but this is a general way to represent our answer. Okay, that is understood that we have the limitation. We will not go beyond that. Okay, and please check here first. We have already defined here that ABC belongs to the set A. So whatever value we will choose of lambda and nu, such that it will satisfy this. It will satisfy the first point. So satisfy the first condition. So we can't select any value of lambda and nu so that A, B, C will go outside it. So we have already assumed here that A, B, C belongs to A. That's why we will take the value of lambda and nu which will satisfy this condition. So please don't get worried that you will get an answer which will not lie in the set A. Okay. So that is not an issue because in the starting only we have assumed that A, B, C belongs to A. This clear? For 4 marks. Okay. Okay, very good. So all of you, please raise your hand if you have noted down this one. Okay, Shravya, very good. Yes, you are correct for 12. Okay, maximum should be 12 for. Okay, Rifat, good. Everyone, please raise your hand if this is right. Okay, Ananya, good. Okay, Amir. Fahad and Abdul, please raise your hand if this is right. Fahad and Abdul. Fahad and Abdul. Okay, Fahad. Abdul, shall we start next? Abdul, I'm going to start next one, okay? Please let me know if you miss anything. Okay, now please check the next part. Next is, now, next part, this is a very, very important thing. Equivalence class, okay? So here they are saying find the set of elements related to one, that is equivalence class one. What is the equivalent class? Equivalent class means you need to find all the numbers which are related to one under this condition. Okay, so that means you need to select from set A all the elements which will satisfy this condition. Equivalence class. Okay, this I will again explain to you in a new question. Equivalence class one is equal to. So please select from this set any number so that, for example, if we will take one, for example, we will take one from here. One is already there. So if we will take one from here, then what will happen? 1 comma 1 is equal to 0, which is a multiple of 4. So similar, equivalence class of 1 is equal to 1. If you will take 5, then 1 minus 5 is 4. If you will take, for example, 9, okay, after this only 159. Okay, so what's the equivalent class of 1? 159, because if you will subtract these two, uh, the for the ordered pair we have to make with 1 only. Okay, so 1 comma 1 belongs to the relation R. 1 comma 5 belongs to the relation R. 1 comma 9 belongs to the relation R. Okay, not 5 and 9. Yes, but they are saying to find the equivalent class of 1. Okay, so we need to find all the numbers from the set A. When we will subtract it from 1, we will get a multiple of 4. So we don't need to select a number randomly. We need to select the number according to this one. Yes, okay. So always remember what is the equivalence class. I will write here. Equivalence class 1 is a set of all the numbers is a set of all the numbers. Equivalent class 1 is a set of all the numbers from the set A which satisfy the given relation R. Okay, please check this again. What is meant by equivalence class? Equivalent class means you need to select all the numbers from this set. Equivalence class 1 is a set of all the numbers from the set A. Just give me a minute. From the set A, which is related to 1, which is related to 1 under the relation R. Okay. So equivalence class 1 is a set of all the numbers from the set A which is related to 1 under the relation R. So that means if we need to find the equivalence class of 1, then we need to select all the numbers from the set A which are related to 1 under the relation R. So for Equivalence class can't be any number. Only those number which are related to, in this question, which are related to 1 under the relation R. Okay, so you can understood in this way that your ordered pair is AB. So A, you need to find this value is fixed. Please try to understand in this way that fix this value 1. This is already given. You need to find A. Okay, so this means what? A minus 1 should be a multiple of 4. Okay, so please check here. So what values we can select from this set? We can select 1, we can select 5, we can select 9. Why? Because when you will subtract 1 from 1, you will get a 0. When you will subtract 5 from 1, you will get a 4. When you will subtract 1 from 9, you will get a 8, which is a multiple of 4. So everyone, please again raise your hand if this is clear. Okay, and you have completed this. Then we will start the next question. Okay, fine. Everyone, please raise your hand if this is done. Okay, Shravya, good. Okay, Ananya, very good. Okay, Rifat, good. Abdur, Umair, please confirm.
So wait, I'm writing.
Okay. Abdur, last slide means transitive. Okay, Abdur, will you please note down this one? Okay, leave some space, write down this equivalence class. Okay, done. Okay, okay, Abdur. Just give me a minute. Umair, please confirm once it is done. There's no need to write this.
Done, sir.
Okay, good. Okay, Abdul, please note down this and confirm me once it is done. Okay, Abdul, very good. First, after this chapter, we will start inverse, okay? And after inverse, we will start the continuity and differentiability. Okay, this question is your homework. But in inverse, we do not take so much time, okay? We'll try to complete that in few classes. Relation function is a difficult chapter, so more time is required in this. So everyone, please note down this. This question is your homework because there's a simple question. You can do this on your own. Okay. So please note down this and raise your hand once this is done. Yes, Ravia, that is composition of function has been deleted. Okay. I guess, Shravya, in your batch, we have already marked that which exercises has been deleted. Yeah. So everyone please note down this question and confirm. Shavit, this is second batch, okay? So it's your wish, whichever timing suits you, you can join that batch. In both the batches, we are doing relation functions. Okay, another batch function has already started. And this one, I guess today it is not possible, but from tomorrow, at that time you have other class. So no issue, can join this batch. Okay. Everyone, please raise your hand if you noted down this question. Then we will start next. This question is homework. Okay. Yes, we will do. Okay, but in the backup classes. Okay, in the regular one, we are doing relation function. After that, we will start inverse. But for example, 30 minutes earlier, the new students will join and we will do for 30 minutes matrices. And after that, again, we will continue the same chapter. Everyone, please raise your hand if this is done so that we can start the next question. Okay, Abdul, very good. Okay, Fahd, good. Okay, Rifat. Rest of the students, please confirm. Okay, Ananya, very good. Fahad, Shravya, Umair, please confirm if this is done. Fahad, okay, Shravya, Fahad, this is done. Okay, Umair, I guess you have completed this. Okay, so we are going to start next question. Okay, so this is a very, very good question. This question came in CBSE 2010. So there are three questions of this type. For example, question number 8, then this question number 9, okay, then this question number 10, and this is a very simple question 11. So this will be your homework. So now we have this question number 8, 9, 10. So these are similar type of questions. One question we will do in the class and rest of the questions you will do in the homework. Okay. Okay, please check here. What is the question? Prove that the relation R on the set n by n defined by ABRCD is equal to this is an equivalence relation. Please check here. So please read this question. You might face, you can see there is a difference in this question and in all the questions which we have done till now. Okay, here they are saying this is related to this. This belongs to the relation n by n. If you will check any previous question, for example, this. Here you have a set A, okay, and this is even. If you will check any other question, for example, this. So there is a difference. Anyone can tell me the difference in this question and all the previous one? No? Okay, please check here. They are saying prove that the relation are on the set n by n. Set of, yes, for you are correct. Here they are saying the set of n by n. Okay. Prove that the relation are on the set n by n defined by this one. So normally what happened, we get the set n only. Till now, whatever the question we have solved, here we have the set n only. But here they have given the n by n. So that means there will not be a single element. We need to select the ordered pairs. For example, in set n, you have the values like 1, 2, 3. Yes, cross product. But in n by n, you have the values like this. 1 by 1, comma 1 by 2, and so on. Okay. Similarly, you can see the relation. Normally, what happened? We get like this. A is related to B. But here they are saying that AB is related to CD. Okay. So that means in place of a single element, now we have a ordered pair. Now, what is our relation ABCD? And here they are saying that how they are related to each other. First element will be added to the fourth one. Second will be added to the third one. For all AB, CD belongs to n by n, there is an equivalence relation, and we need to find the equivalence class. Equivalence class we will do later on. Please check here. Okay, so we will start with reflexive. Reflexive. Can you try this question now? Okay, I will do this. Let A comma B belongs to wait. We will assume let A comma B belongs to n cross. Okay. Why we have chosen A comma B in reflexive and not A? Because here we need to take the ordered pair. Okay. So here A comma B belongs to n cross n. Next, this implies A comma B belongs to n. Okay. Now we will write like this: A plus D. A plus D means if we will write like this, A plus B is equal to B plus A. If we can say like this, A plus B is equal to B plus A, then we can say that A comma B is related with A comma B, hence the given relation, hence the given relation, hence the given relation is reflexive. Okay. So everyone please note down this and let me know if you have any doubt in this question. Yes, we need to take the natural number. This is clear to everyone that why we have taken A comma B and not A comma and not A, only
So
A.
can you explain that again? Why
Yes.
I would take?
Yes. Please check here. Here we have a Cartesian product and crossing. Okay. So normally what we take a single element, but as the Cartesian product is given, that's why we need to assume a ordered pair. Okay. So our first value will be an ordered pair. That's why we have assumed here A comma B belongs to n cross n. Now we need this condition, this one, because if we will get this condition, then we can prove this one. What is the condition? A plus D, that means first and fourth, is equal to B plus C, that means second and third. Please check here. AB related with AB. What is the first value? A. What is the fourth value? D. This one, B. What is the second value? B. What is the C is what? First value. So we have written this A plus B is equal to B plus A. Okay, A plus B is equal to B plus A. So that's why A comma B is related with A comma B. Hence the given relation is reflexive. If anyone have a doubt in this, then please let me know. Okay, you might get confused because here we need to assume the ordered pair. Till now in every question you have assumed a single value. Okay. First your doubt is why A plus B is equal to B plus A, because we need to prove this first, because we have assumed our ordered pair. Okay. The first thing is you understood this, that why we have taken A comma B. For example, in the previous question, here what we have assumed, let A belongs to A. Okay, this set is given and we have assumed this one for reflexive. If we will check in this also in reflexive, we have assumed A belongs to A. But in this question, we are assuming A comma B belongs to N cross N. This is clear, Abdur, why we have assumed this?
Yes, sir.
Okay, because the set of ordered set of Cartesian product is given. Single natural number is not given. They have given you Cartesian product. So you need to select every value from the Cartesian product. That's why we need to select the ordered pair. So we have assumed this one, A comma B. For reflexive, if our first value is A comma B, then observe what should be the next value? A comma B related with what? For example, in the previous cases, no, in the previous cases, we always write like this, that A is related with A. Okay. Here, what we will write? Our first element is AB. For reflexive, we will write AB, not B, AB. For reflexive, what is a reflexive? Every element is related to itself. So we have AB. So AB should be related to AB. This is clear, Abdur. This we need in the final result. Abdur, okay. Now, what is mean by this one? Put this condition. What is the condition? A plus D. D means the fourth element. Fourth is what? B. First is what? A. A plus B is equal to B means second element, B. Here second is B. C means third. Third is A. So first we should have this condition A plus B is equal to B plus A. That's why I have written this A plus B is equal to B plus A. We know that this is the same thing. LHS and RHS is the same thing. That's why A plus B is equal to B plus A. Now, as per this condition, we can say that A comma B related with A comma B. Why? Because as per the condition, if you will apply the condition here, you will get the same result. Now this is clear, Abdur. Okay. Everyone, this is clear, reflexive. Please, how do you apply the relation?
Yes, sir.
Okay, very good. Everyone, please raise your hand who have completed this, and this is clear. Okay. Okay, Shavya, very good. Okay, Fahad and Anya. How I apply this relation, please check here. What is the relation of the first? I will rub this. Hmm. So please check here. What is the condition of the? This is the first element. This is the fourth element. This is the second element. This is the third element. So what is the condition? First plus fourth is equal to second plus third. Check here. This is first, this is second, this is third, and this is fourth. Okay. So what is the condition? 1 plus 4 is equal to 2 plus 3. So 1 is A. Okay. What is fourth in this, Abdul? What is the fourth value here? B. Okay. This is the fourth value. What is the second value? Again, B. What is the third value? A. This is clear?
Yes, sir.
Okay. Okay. As the given relation is reflexive, almost time has already been done. Okay. I will take now 1.5 hour class. Okay. Because most of you get tired and some of you always left the class after 1.5 hour. Okay, and Fahad is already doing the class for the last 2 hours. So I hope this is clear to you. Please try to do the same question for symmetric and transitive. Okay, and I will solve this question tomorrow for the symmetric and transitive. Okay, and now what is your homework? Please note down this question. This is your homework. This is your homework. Please, or leave this. We will do this tomorrow. Okay. So your homework is please revise all the topics which we have covered today. Do the homework which I have given you in the previous class. Okay. And then we will continue this question tomorrow. Okay. So if anyone have a doubt, then they can ask me. Otherwise, we can end our class. Okay, so I guess no one has any doubt. So, okay, thank you so much. We will continue the same question tomorrow.
Thank you, sir.
Okay, you're welcome.
Thank you, sir.
You're welcome. Fahad, do you have any doubt? You're welcome. Okay. Okay, Fahad. You are first.